Today's job is we are starting a brand new project, and we have to build a phylogeny of bees. I've done this several times before, and I've generally got the pipeline to do this, but no two projects are ever exactly the same, because the applications are different, data is always different, and requirements are always different. So, but we'll make a start of this phylogeny, and we'll start by mining some barcodes. So this is going to be a species level phylogeny. So starting a brand new project, obviously already a lot of the framework already to do this. So in practice that means the list of commands from some previous projects. So I have two. This is for bees. This was done maybe 1 or 2 years ago. More recent one, well, not the same taxon, but more recent set of commands. So I'll be consulting. In practice, this just means copying commands over and checking results and modifying as accordingly. So first set of commands, this is a phylogeny of bees. So I've obtained all DNA barcodes for bees. And these are a set of commands. We use wget, which is a Linux command just for downloading a file from the internet. We're using the bold API, which allows you to obtain all barcodes for some given taxon. But I recommend separating as much as you can, separating the taxon into a set of subtaxon, and then checking these. So the connection to the servers for bold are in Canada, and sometimes fast, sometimes slow, depending on which country you're in, time of day and time of week. And these will all impact the speed, but in this instance it's actually run very quickly. So if you've done this before, better to check. As I say, this is about, actually I've got the date. So last time I ran this for another project was July 2020. Date now is May 2022, so it's about two year difference. Let's just have a look at these files and see what's changed in 2 years. So these are all collected barcodes. So we have a file of 2.3 megabytes in July 2020, and today 3.3 megabytes. So quite a big difference in just 2 years. Electricity 2 years ago 8.3 megabytes. Electricity 11. So obviously you should be getting more. Now remember, bear in mind this can be interrupted, and maybe not even an error message to alert you. So certainly you should be getting more data as if you run a download subsequently. Megachylids 2 years ago 3.9 MB, megachylids today 4.9. Okay, so this all looks fine. Honeybee family 2 years ago 16 megabytes, today honeybees 19.8. So this all looks good. So we'll start by just copying over some of these commands from these other files. And these probably should be about the same. So we're going to combine. So downloaded a FASTA file for 1, 2, 3, 4, 5, 6, 7, 8 families. And just combine this into a single file using cat. So there's various barcode markers uploaded to bold. There's for animals, there's always a predominant one, which is co1 5 prime, but consider that there are others usually present. So we need to just pull out, in case, well, we need to pull out this single, the standard marker, which is the most frequent one. So this is a grep which scans any file, and we're looking for a faster delimiter, which is the forward arrow, and the marker string co1 5 prime in the ID. That's when we know. Now this is a silly little thing we need to add on. I'm not sure why this happens. We'll get an extra couple of dashes added somewhere. I don't know the reason for this. So you can see a reduction in the size. So there were some other markers in there. And let's just count. So grep for the ID line, and just count the number of lines. That will give us a count. Always keep records of how many we have. If something goes wrong, it's a bit more obvious if we have records. And we can actually just check. 41,000, and we have a few more here. Okay. Next. So in insects, you get a lot of unlabeled stuff. Let's ignore those. Just go for the fully taxonomically labeled stuff. So I have genus, species. Genus starts with a capital letter and then it has lowercase. Then you have a space, then a set of lowercase. So that's what we're scanning for here. Put that into a new file. Yep, so about a quarter of these will have been not correctly assigned, well, not fully taxonomically assigned, or assigned with some unconventional label, which is a bit awkward to work with. So I'll just get the easy stuff out. Perl script to simplify the faster ID lines. Let's see if this is something I noticed on a previous project. We have this, I forgot what this stands for, but these are nuclear homologs of mitochondrial genes, which have been sort of copied into the nuclear genome and become inactivated and degraded. And these are usually these are picked up during any sequencing project, and they're not actually, I don't think they're actually uploaded to any repository because they stick out like a sore thumb. They're really full of gaps and stuff, so they're not usually uploaded. But in this case, I think this is actually a project on nums, so they did upload these, and these need to be removed. Let's have a look if these are still in here. And that does it right. And that doesn't. Let's try that again. Okay, it doesn't seems these are not in here. So just going to skip over this then. Let's assume these are. I'm not sure why these are in previously and not in there now. Okay, where were we? Add an outgroup. That sounds like a good idea. We'll see if that file is actually still in that location though. Yep, it is an error message. So that's an outgroup. And a line. I'll have to change this name here. Yep. Okay, so this will be in a different location now. Let me just check. Okay, I'll change this location to something else. So this is a reference alignment, or we might call it a sort of a profile alignment. And then doing pairwise alignment against the box. This is like a created, so check carefully. But this is generic for insects. It's better to have a specific one for bees, as this is a bee project. I'm not sure that I did this. I've got one for this. Got one for hoverflies. I should really do one for bees, because so a lot of high throughput profile aligners they'll do a blast search against the created reference alignment, and just like for the top hit they'll do the pairwise, say NW alignment or something. But if your reference, if the stuff in your references is too dissimilar to your subject, then your queries, then sometimes you're not going to get hits, and this is not going to see these are going to be ignored and not removed. So you need your reference alignment or needs to be somewhat relevant to your subjects. So I should really have. I need to make a note. I'll make a B reference alignment at some point. I need to do that. Some job needs doing. I always do this. If you write to do, so anytime you're doing corrections or something, just search for to do, and so then you can decide if you want to do. If you want to add that to a list of jobs. Often when you're working on corrections, you need to go through the whole process again. So that's when you're doing the whole thing. That's the time to make get various jobs done at the same time, and it makes it easy to find them. Just type in to do. Anyway, so we'll just use this insect-wide reference alignment. This is based on the original Herbert 2003, one of the earliest barcode papers. So they had a reference alignment for insects. So just I went through that and so trimmed it exactly. So it's nice and neat. One limitation of this is it's optimized for colon. It doesn't work on if you have gaps. It's something I need to improve with this script. I'll do that. One job needs doing. So here's so we have to run this high throughput alignment. You do a reference alignment, which is what you're going to align it against. Unalign file delete the files if present, which we probably don't have at the moment. Need BLAST that determines what's the best top hit, what's the most similar reference sequence to each of the queries, and then the alignment script. So there's a bunch of different high throughput aligners which do pretty similar thing. This is the one I wrote myself. So let's just get on with this. So BLAST search followed by parsing the BLAST results and for each hit doing pairwise Needleman bunch alignment, which is global alignment. And this these values, so you need a gap parameters. I optimized this some time ago, so these should be okay. But sometimes you lose a few sequences in this process for various reasons. Okay, alignment finished. Let's take a look. 42,000 barcodes after alignment. Scratch that. Next is species filtering. $3,700 species. Okay, so this is a collaborative project, and there are specific study subjects which are in this file here. So let's have a look. Someone's just sent me this list of species. So we have a 2-column file, first with the genus name, second with abbreviated genus name and the species name. So first we need to, before we go any further, we need to check how much overlap we have in our barcodes that were just downloaded and processed and aligned and filtered. See what kind of overlap we have. But this is quite a big file. So yeah, there's a lot of species in here. So I'm guessing we're going to have to find a lot more than what we've actually got from Bold. But let's just check this, see what type of overlap we do have. Just write a bit of Perl code to have a look at this. we have two files, species list of the study subjects, and we have the FASTA file from bold, and these two files we'll put into this Perl script like this. Hold on, so we have the bold file first and then species list second. Okay, so we open the bold file, scan each line and print each line. So I just need the ID lines, which start with the forward arrow, have a conditional, start of line, forward arrow. So genus underscore species underscore accession. So let's just pull out the binomial genus and species. And then store these in a hash. And anything which doesn't have this, let's just check what that is. And these are just just have a check here maybe. There should be none of this. Okay, yeah, that's fine. Okay, so we've stored the Right, let's just print this, check with capturing what we think we are. Okay. So we stored all the binomials from the bold FASTA file into this hash here. Now let's open the file of study subjects from our collaborator and see what kind of overlap we have. Change the file handle to something else. First I just print everything we encounter, see what it looks like. Yep, so we have this 2 columns. Tab separated. And then we have should be a single letter followed by a dot, followed by a space, followed by a word. And that will be the start of line. So this will be the genus name. Here's the tab. This will be the genus abbreviation, which we don't need. This will be full stop, space, and this should be the species name. Yeah. So I have 2 things we're pulling out of here. So let's check this is pulling what we want. Okay, yep, this looks like a genus species. I noticed we have some ambiguous things also. Let's just print a line also. See exactly what we're dealing with. Got a new line and that tab. So the line in the file, genus tab, species. Yeah, okay, this looks fine. So we have this is very common in insects. We have identification is a lot more difficult than other things. So often it's only feasible to identify a genus. So you get this a lot. This is unknown species. And at this stage, probably probably just have to ignore these. So there might be various ways this is written. For now, let's just, within here, we'll just refer back to this hash and see if it's present or not. So here we have underscore separating the genus and species. So we need to make this into the same format. Yep. So we have a conditional, see if it's present in this hash from bold. If, and we just assigned one, so we'll check if this equals 1. And we'll count these. Okay, oh dear. So unfortunately we don't have much overlap. So the list of species from our collaborator, how much were they? 2,157. After those, 876 have a DNA barcode or have actually a match for the binomial in the barcode data. 1,246 do not, which is unfortunately quite a large number. So this is going to be, as often, not particularly simple as one would hope. So there's going to be various things need doing. I'm going to have to look at genus and subgenus mix-ups. People often put their bold data with, they often put their subgenus name as a genus, and try and account for that. I'll supplement this with NCBI data, so I'll download bold barcodes from there also. So that's going to take a while. but there's a lot missing. Might have to look at using other markers also. So 3' and RNA markers might get a few more numbers up. If that doesn't cover everything, then I have to figure out some way of maybe some taxonomic placement where there's no molecular data. Okay, so we just started this project, and it's never simple, even though you're working with the same things. Yeah, this is going to might turn out to be a bit awkward, but let's get it done. I think that's enough for today. This is going to take quite a number of sittings to get some, even just the species level data, before we even think about the backbones and so on. Okay, goodbye for now.